Welcome to Study Loop.
Okay, the question is that when a resistor R1 is connected to an EMF E, it consumes electrical power P1. So P1 can be written as E squared by R1, right? So from this expression we can write resistance R1 as E squared by P. So this is what the first sentence gives us. Now, when the second resistor R2 is connected to the same EMF, it consumes electrical power P2. So for the second resistor R2, the power is P2. So E squared upon R2. Alright. So this gives me R2 equals to E squared by, okay, I missed one here, squared by P2. Right. Okay, this is from the second statement. Now the question is asking us in terms of P1 and P2, what is the total electric power when they are connected to the same EMF in parallel? So first let us do it and the connection in parallel. Now when they are connected in parallel, when R1 and R2 are connected in parallel, then the equivalent resistance Req would be R1 parallel R2, right? So equivalent resistance would be R1 into R2 upon R1 plus R2, right? Right. Now if you do this, this turns out to be E squared divided by P1 plus P2. Okay, so the power now would be E squared by Req, right? Now if you divide Req by E squared, you get P1 plus P2. Very simple, right? So before, when they were connected individually, the power that they consumed was P1 and P2 separately, and now if they are connected in parallel, there is no difference. They again consume power P1 plus P2 together, right? Now in series. Now if they are connected in series, so what happens? So now the equivalent resistance Req could be how much? Simple R1 plus R2, right? Now if you add R1 plus R2, this will become E squared times 1 by P1 plus 1 by P2, right? Right. So what would be the power now? So now power would be E squared by Req, and that would be E squared divided by Req would be reciprocal of 1 by P1 plus 1 by P2, and that is P1 P2 upon P1 plus P2. Alright, so this is the required power when they are connected in series, and this is the required power when they are connected in parallel. So we are done with the solution of this question.